click, off, click. Your nitrile gloves. Discharge. Hello and welcome to Starboard Science. Today we will be acetylating salicylic acid and we will be making acetylsalicylic acid, also known as aspirin, the painkiller. Salicylic acid is derived from the bark of the willow tree and being used as a folk remedy for many hundreds of years. However, its acetylated version is very much better tolerated by the body and generally has is very much more effective at what it does and how it does it. So we'll be making it. Now, what happens here is that the hydroxyl group of the salicylic acid reacts with acetic anhydride and forms acetylsalicylic acid and a molecule of acetic acid. Now this reaction does not progress by itself, it needs catalysts. The common catalyst used is just concentrated sulfuric acid, but my sulfuric acid has some moisture in it, it's not completely dry, like 98%. That would be required, so I will be also using aluminium trichloride, which serves two purposes. One is to drive off the remaining water of the reaction of the sulfuric acid, and two, it's a strong Lewis acid that also participates itself as a catalyst in the reaction and drives it forward. So what I got here is 2 grams of salicylic acid, and now I'm gonna go ahead and add about 30 milliliters of acetic anhydride, which is overkill. However, it's not just the reagent but the solvent for this reaction. And start stirring the mixture. Now, after everything dissolves, we will add the catalysts. everything has dissolved. Now, before adding the catalysts, I wanna do a ferric chloride test that we will also perform in the end of the reaction. So we'll go over here. Let's have a small volume of water, and I will add some ferric chloride. And I'll take a small sample of the reaction mixture and drip it in, and if there's a phenol present, it should turn violet. And as you can see, it turned violet. I have to dilute it to see how violet it turned. So that confirms the presence of a phenol. Our end product should not give this test with the iron chloride. So now I will be adding the sulfuric acid, which is only a few drops, which is only what I have left. So I guess that's okay. Next, we'll be adding a few milligrams of the aluminum trichloride. And then leaving there this thing to react for about 20 minutes. Okay, so 15 minutes have passed. I think it's time to do another ferric chloride test, because I believe this is near completion now. Maybe it's even complete. I do not wanna convert every single molecule into acetylsalicylic acid. It would be ideal, but chemistry is not ideal. Ideals are ideal, and I do not believe in any ideals. So Ferric chloride test, I'd say maybe negative. If there's a slight color change, I'd say many part per million of salicylic acid in there. Most of it has been converted, so it's time to stop the reaction, filter the mixture and quench it with water, cool it down and filter out the crystals. But phenol wise, there's no salicylic acid left in there, and this confirms it. Now we filter our solution and it's time to quench it. However, as someone who's been doing chemistry and has been beaten in the ass before many times, I prefer to do things in batches. So I'm not gonna put all my eggs in one basket here, and I'm gonna quench half of our mix and, you know, see what happens. Well, that is to be expected, I guess. You're hydrolyzing acetic anhydride. So with this being so hot right now, there's no way of crystals to precipitate, so I will have to cool this down in the freezer and wait for crystals to form. So after leaving the solution in the freezer, here's what I got. It's a milky solution with crystals on the bottom, and so is the second batch. So now we'll filter it and we're gonna wash it with water, remove the acids and all the other stuff that is present in there, and then dry it and wait. So this is what I got after filtering both batches. Now let's wash it with some water. And here is our product drying, you guys. Look at these beautiful crystals, if my camera focuses. Where's my spatula? I wanna... I wanna ruffle them up. As you look at that, that is definitely not salicylic acid. I can tell you that just from the morphology of the crystal. Salicylic acid would be like needles, interlocking fine needles. That's definitely not salicylic acid. I think we successfully acetylated it. Now the yield is a bit shitty, but I'm not Bayern, I'm Starborn Science, so yeah, let's let the product dry and then I'll try to weigh it, because my milligram scale is out of the game right now, as it was attacked by EMI from a Tesla coil, and let's say it does not longer calculate weight very much accurately. So I will use my other scale, which is a bit well, doesn't have that much sensitivity. Still, we put in 2 grams. This looks like half a gram, maybe less. I don't know if it will even register on the scale, but still, it's something. Now what I really wanna do is take a sample of this thing, put it in here and run a ferric chloride test to it. So let me dissolve it in some water, ethanol, and we'll do the test. I don't seem to have any ethanol, but isopropanol will do just fine. So we get the ferric chloride, and let's hope it doesn't turn purple. And nope, this is not a phenol, you guys. This is most likely acetylsalicylic acid, and we've acetylated the phenol and successfully made the acetylsalicylic acid. And since we have the test over here, I will do a control test for you. Since we have the ferric chloride, here is some acetylsalicylic acid. Which would turn the reagent purple instantly. So we know we have something that's not acetylsalicylic acid. Now, could it be something else? Very well, it could. Is there anything else it could really be? I don't think so. It's most likely acetylsalicylic acid. Do I have a melting point temperature device? No, I do not. I can do a melting point temperature test. Do I have NMR? No, I do not have. Do I have mass spectrometry to do? No, I do not. Do I have HPLC? No, I do not. So, all I do have is a ferric chloride test and just the crystal morphology to go about. So judging by that, I can only suggest that this is acetylsalicylic acid. Other than that, I have now no other proof to show to you guys and girls and whatever else that this is acetylsalicylic acid. It most likely is. Now, nothing is certain until you have concrete proof. Is the ferric chloride concrete proof? It's concrete proof that it's not a phenol anymore. That much we know. But anyway. There you go, people. Oops, what happened? It said half a gram. I saw it. I know you saw it too. Where's my gram? Yo. Hey, don't steal. Don't cheat. It said half a gram. I'm gonna suppose it was half a gram. Let me remeasure it again. Now it says 0.6. Well, I'll say 0.5. Just to be fair with the scale. I'll say 0.5, not 0.6. 0.6 seems a bit too generous for the scale. So, 0.5. 0.5. I'll take 0.5. It doesn't even turn the fuck off. It didn't, so. Okay, so 0.5 grams. So that makes my percentage yield on starting 2 grams on about 19.2, so I'll say 19%, which is, well, abysmal. Yet it's something. So, given that the ferric chloride test came completely negative, and given the fact that we believe that this is acetylsalicylic acid, I'd say that the experiment was a success. So yeah. So here is the sample, bottled up. It's still crude as it came of the reaction. I would recrystallize it, but it's just so little, like half a gram, that recrystallization would leave me with almost nothing. I think it's pointless. It's not to be used as medicine or anything. It's just proof of concept. So I will leave it as is and name it crude acetylsalicylic acid. So, this was today's video. I hope you liked it. I hope you learned something about esterification reactions, which is what's happening over here. We are reacting in essence an anhydride of an acid, of acetic acid, with an alcohol, a phenol, to create its ester, which is the acetylsalicylic acid. And yeah, so I hope you learned something. Hope you enjoyed the video. Keep dreaming, keep exploring, and I will see you on the next one.